Welcome? Question mark? Do we hear people?
Hi, guys.
Or hey, I see some faces. Andy.
Hey, Brooke.
Dude, you are spending way too much time buying cool lighting fixtures for your background in your video. I want whatever you have there. That's brilliant. Ava?
Hi.
Welcome.
Thank you. Excited to be here.
Good to see you. Ben, how you doing? I don't hear you yet. I think you're muted. And William, welcome.
Yeah, I'm doing good. Staying safe and healthy.
Where you at, Ben?
Outside of Washington, D.C.
Oh, wow. Lots of activity over there, huh?
Oh, yeah.
Well, good to see you, sir. Thanks for joining us.
Yeah. Well, I had one of your old printer bots, so I was curious what was going on.
All right. Which one, if you don't mind me asking?
The bigger of the two. I forgot what it's called.
Is it made of metal or wood?
No, it's metal.
Metal, so the plus,
Yeah,
simple,
it's the plus.
the plus, yeah. I'm doing a riff on that soon, so you'll see more.
Cool.
Well, that's great.
Okay.
Kurt, what's up?
I'm not talking at the moment just because I'm letting people into the room, admitting them one by one. Everyone's coming on board now.
This is great fun.
Yeah, I've got an original laser cut plus and
What?
a simple metal.
How old are you?
I'm old.
That's great. Thank you, Kurt. It's good to see you, man. Where are you at?
I'm also just outside of DC. I'm in Rockville, Maryland.
Oh, that's great. It's snowing, right?
Later today.
Not
Okay.
yet. Not yet.
Add some, right?
Maybe 3 inches this afternoon, and it's tomorrow morning, and then a second storm for maybe another 3 or 4.
Yeah, I've got a little snow in Kansas today.
Yeah.
It's beautiful. Welcome, Chuck. Now, Ian, you're going to have to tell me, do I need to hit the arrow to see? Oh, there's even more people.
Yeah, there's more people.
Grant, Sam, Apsu, Kevin. Now they're coming in.
Yeah, we are up to 18.
Oh, that's great. Well, welcome, everyone. Ian, I'll shut up and let you talk.
Yeah, well, welcome everybody to Plybot, first demo that we've done on the back of this Kickstarter campaign. I'm just admitting people as I talk at the same time. So the idea of this was just to have a little bit of fun with everybody, really, and bring you in on the journey that we're going on. A lot of you probably know of Brook from Plybot, and when he's been on TV as well, All American Makers, and obviously we'll introduce you to Josh and Pontus shortly. But what we wanted to do is ultimately share with you the progress that we're making on Plybot. You know, a lot of the things that you see on Kickstarter tend to be a bit smoke and mirrors, nice visuals, nice videos, nice animations, but lots of question marks on, is it actually real? Have they done anything? So what we wanted to do is, rather than try and convince everybody that Plybot is real, we are real people and there is an actual machine that works. And we're still, you know, five months before our shipping date. We wanted to bring you in on that journey and sort of show, you know, we're excited to show where we're at with things. We're also happy to answer more technical questions on the machine, how we're doing things, and what our vision is for Plybot. So I'm not going to do a huge amount of talking. I'll just say we'll go around the room in terms of who everybody is. Brook?
I'm Brook.
Yep.
And let me tell you, the one thing I want to say is, Nobody knows who Ian is. No offense, Ian.
That's fine.
But this is a dude I trust. Super awesome dude. And my thing is, I've been in business long enough with 3D printers to know that there's a lot of guys that'll waste your time, and there's a few people out there that are just solid and that will not waste your time. Ian's one of them. Pontus, Josh, they're all here. I trust all of them. So let's pass it off to Josh. Say something.
Sure. Hi guys, I'm Josh. I'm 21. I'm from England. So I started Plybot. So originally I got into 3D printing when I was about 13. So from age 13 to about 18, I bought a lot of 3D printers. Then I entered the British Science Fair. So I won it with Plybot, which was originally a master machine made out of plywood. So yeah, that was 3 years ago. So I joined forces with Ian. Brook came on a few months later. And yeah, I've been working on this for the past 3 years. So I'm currently a sophomore at Stanford studying computer science. Yeah, that's me.
Pontus, go.
Hi, I'm Pontus. I've been playing around with these kind of arm printers for maybe two and a half years now, and these guys found me like half a year ago or so. Like, hey, do you want to join us? It's like, what? They're building. Oh, that's interesting. I know that.
Dude, when you're on YouTube, you're going to be found. So it's your fault. You put yourself out there and we found you.
That's the idea.
If you guys have not seen his work, you should go on YouTube and see what he's doing. It was very, very special. And check some of the GitHub. You can see he's a contributor to this style of printer. Just a great guy, very talented.
Excellent, excellent. So that's the team. That's what we've got at the moment. And you know, between us, we're doing our best to bring Plybot to life, both as a proposition, something that really makes 3D printing simple for the first time, and secondly, to make sure that everything gets shipped on time in accordance with the pledges, and bring everybody on that journey. So I'm going to make the screen a bit bigger for Brook. As you can see there, we've got Plybot up, running, printing at the moment. Brook can talk you through that now. Let me just go big on Brook.
That's a mistake.
Oh, we're getting there, Brook. You're getting bigger. Whoa.
Oh,
Well,
I recognize some of these names. This is hilarious.
go, Brook. I'll make Pontus small in a second when my computer goes.
I don't know what you're doing. It's magic to me, man. Now, Ian, how do people ask questions? Because I would love to just hear. I don't pretend to know.
Well, we've got two options here. People can speak and throw a question in there, or they can type it in, and I will read them out to you, Brook, so that you can go through.
Okay. Oh, there we go. I'd love to hear some questions. Just like, what are people thinking, and what?
Well, some questions, Brook. It seems like it's pretty quiet. Is it close enough to the camera to pick up the sound?
Yeah, my wife I was telling the guys, we did a little pre-show test, and this has been printing for, I don't know, over an hour. And my wife came in to help me with the lighting, and she's used to printer bots, the 8-bit machines. And she was in here, we were adjusting lights, and she said, I cannot believe how quiet this is. This is weird. If you guys have a 32-bit machine with trinamic drivers, it's a completely different story. It is, it's the mic is here at arm's length. I'm like 6 inches to 8 inches. It is so quiet. The only thing I hear is actually the fan. And to be fair, I have to say, I've been telling Ian, because I'm watching all the costs on everything that we've designed here. That fan is expensive. So I'm not guaranteeing that fan, but that fan is silent. It's like so quiet. It's ridiculous. So that's the Noctua fan, if I'm saying that right.
Yeah, you are.
Yeah, that's kind of like awesome. but I've heard that from some like gaming PC guys that there's other stuff out there that's a little more economical. So we're going to look for the best bang for the buck. And that's the whole thing with Plybot is we want a great machine that's super easy to use, that has software that makes it easy. If you don't want that software, you can do your own thing. We're not locking anything down. We want it for makers. We want it for newbies. We want it. If you saw my first Kickstarter, you know that my kind of metric is, can my wife print? And she learned a lot and was able to print on the old stuff, but she did not enjoy it. I'm just being honest. You know, with the slicing and the finding the files and inches versus millimeters and all of that. But the goal here is to make it easy for anyone to print. So that's the true goal. We don't want to lock anybody down. We want to, if you guys enjoy your own software, slicing your own stuff, that's all good. But one of the things that she did not like was the machines were loud. I've got 2 stories in my house here in Kansas. When we get in bed and we're saying goodnight to each other, we can hear the printer bots downstairs. But we're in the room, when she's in the room with the Plybot, she can't tell it's on. Honest truth. This is super quiet, but we didn't do anything like that special. We're just using 32-bit trinamic or 32-bit ARM stuff, trinamic drivers, quiet fans. You make the right decisions and it can be very, very, very quiet. It is very quiet.
How is leveling done?
So you don't, you might be able to see it. Okay, yeah, look right there.
That's what I thought.
Yeah, at the back there, right behind the fan. And you got to give me a little leeway here. This may change. Pontus is our software guy. And when we were discussing, can we do auto bed leveling? He said, yes. Eventually, we'll figure that out. Now, I know that Pontus, can you speak to it? What is the, and full disclosure, right now we're using a Raspberry Pi Clipper and a SKR board. That's the beta. We don't want to commit to anything quite yet because we want to save the most money possible, but we don't want to give up any features. So if you can speak to Clipper and where they are with auto leveling, Pontus.
Well, auto leveling works perfectly fine in Clipper. There's a little tricky part here since the probe is moving around in an offset from the hot end.
Right.
And that often depends on where we are, so we need to do that.
Yeah, so it's a moving target. You can see that as it rotates, you know, the sensor is rotating on a concentric circle with the hot end. So I'm sorry, Pontus, you're gonna have to deal with it. How do you do that? Is it possible?
I know my trigonometry. It's fine.
He's being modest. When I asked for a map of, because I don't know if you guys know this, but with Scara arm, and I credit Josh for this, you know, he's really come up with a unique, it's a parallel Scara arm, and we fought a little bit. Josh, can you speak to the decisions to make it? The beautiful thing about this printer is it's different, and I credit Josh for that. But what do we gain, Josh, from 2 arms?
Yeah, so I'll first say that the 2 parallel arms came from Nicholas Seward with his RepApp Wally. So this is a slight modification on that. So those are the motors mounted on to the printer, not the arms. So that had a lot of issues with the maths. You basically couldn't do the maths on an 8-bit board. So by mounting the motors to the arms, it simplified the kind of kinematics a lot. So you could do the maths. So you didn't need these super powerful boards. Yeah, so so I prefer the arms. Obviously, that was my kind of science fair project and my invention. And I like the simplicity. So obviously it's a lot simpler, a lot less moving parts. So that really brought the price down. It's also great from a print volume perspective because it can basically print on everything that isn't behind the Z rails. So right now it's printed about 60% of of the footprint, whereas most printers like 19%. We did the maths on that a few weeks ago. Yeah, the main thing originally was it's very simple, so it makes it a fair bit cheaper, and it also it's just as accurate as a Cartesian in terms of the print quality.
Now, Pontus,
yeah, I'm broke.
I got a question, because I love optimizing. So Pontus, why do you think we have a rectangle here when a true Scara arm is like, what shape is a Scara arm print volume? I mean, it's not square.
It's not square. No, it's weird. It's kind of egg shaped.
The technical term, it's weird. Like, what shape is it though? Describe it.
Well, like a pointy egg, with the point is towards you.
Pointy egg?
I'm not sure how to.
So I remember when Josh and I were trying to figure out, like, and Pontus came on a little later, but me and Josh were trying to find out, like, where should we constrain this? And, we're like, doing bad Photoshop with arcs and stuff, or what, we're just trying to figure it out. And then Pontus shows up and he gets involved, and he goes, let me write a program maybe he already did it. He had a program that he wrote himself that, like, basically took the grid, like in a Cartesian bot, you would have a, X and Y grid where every square is a square and a perfect, and he was like, oh, let me find the optimized place for the print area. What was this program? We should drop the video of, or not video, but the images that he sent us, because when he sent us the image, first of all, it was like minutes later, and it was like this crazy grid. You know how when you put the globe on a flat map, how the lines are, it's a little interesting when you try to make a sphere or a circle on a flat. He wrote a program to do it, so my mind was blown. What is this? We were able to find thanks to Pontus, we were able to find the optimized area that a rectangle would take up on that grid, because when you go out to the further points, it starts to get really squished. Like, the square ends up like, whoop, it's really weird. How do you explain it, Pontus?
I mean, when the arms approach their extreme distances, you get, or their extreme stretch, you get weird effects, and the resolution goes all.
But it's still, you have to tell the motors, where to go on an X and Y grid. So this is it's polar, right? So you have to spread. It's not a globe, really. It's a circle, right?
But it's two circles. I mean, the print area is basically, if you paint two circles and put them on the Z rods where the arms are attached to the print area is basically where both of those circles are.
And it's where they intersect.
Yeah.
The reach of the arms, you draw two circles around those Z's, and it's where they intersect. And then what he showed us was kind of like it was almost like graph paper, like where the X and Y coordinates were, and you can just easily see where it's optimized. So where's the least accurate? Is it at the front here, at the back? Where's the least accurate on this print bed? It would be like way out at the furthest reach, right?
Yeah, it's around that area, which is actually outside the print bed.
Yeah, that's.
We go there, but we don't put a bed there.
I don't even know. Josh, do you know, was the previous printers you mentioned, was it the Morgan or?
It was the Wally.
Wally.
It was similar.
Did it reach beyond its print bed?
I think it did. It never really got working properly. They did a few. I could only find about five prints done.
I've seen one in person.
Yeah, it was never successful.
Yeah, right. The reason you
Yeah, it
don't
was
know
back
what
in
we're
like
talking about
2013.
is because it wasn't a big thing. It was clever though. It was really clever. I love
Yep.
Nicholas Seward, by the way. He's a friend. He's great. Math teacher. Teach high school kids.
So let me just fire in some questions, Brook, Pontus,
Thank you.
Josh, because there's questions coming in on the chat. So have we seen the ADXL345 accelerometer Z probe request on the Clipper GitHub? Where you can use your nozzle as a probe.
We've not seen that, but we've just had that posted in the chat about 5 minutes ago.
Yeah.
So we're going to look into that. We've had that posted in our Slack chat as something to look into.
Yeah, the guy that makes the hot ends, it's hidden now that we've proven that. And can I apologize to everyone that in the photos I thought it was more beautiful without the fan. So my apologies to Ian and others that have answered the question. Where's the cooling fan? Where's the hot end fan? It's right here, but underneath there is, right now we're using a Ubis hot end. It's the stuff that I used at Printrbot for years and years and years. And he is very keen as well. If you've got a 3D printer, wouldn't it be great if you could use the hot end itself as a probe and to probe the bed? You can see on the back of this right here, that's a Pinda 2 sensor. So the typical style, like that Prusa uses, the auto bed leveling. And it is not working yet, just to be fully clear. We've got an aluminum bed that I stuck on here. This design will change slightly. We want to make it look really, really good. I added this after the fact, so you won't see this in the renderings because it's about 1 day old. But it does have a heat bed. The heat bed works. It's got a thermistor under there. This is a magnetic bed right now. I don't want to mess anything up, but that, there's other options here. But when you probe with that Pinda sensor, it has to sense metal. But imagine if you could put any surface down, like glass or aluminum or steel or spring steel, whatever you want to do. It would be great to use that. The hot end maker, Carl, and I have been talking about that for years. We can't really promise anything because I've heard that there's some other companies that have experimented with an accelerometer, but Pontus, can you imagine we could achieve the resolution needed with an accelerometer? Look at his face, people.
It's hard to tell. I haven't tested them myself, so but it might work. It's an interesting application of an accelerometer, for sure. You have to play with that.
M3D or Micro 3D, I forget the name of the company, but they had some kind of thing that they were using. But yeah, I love the reason I love this team is they're so open to innovation. And Pontus, if anybody can figure it out, he's a guy that could. But it would be something that we'd need to test for a long time, and it's certainly nothing that we would ship in the Kickstarter shipments. We want stuff that's been tested and that works right off the bat. So, but auto leveling like this works right off the bat. So that's what we'll commit to.
Okay. Quick question: filament, is it 1.75 millimeter filament?
Yes.
Okay, great. What's the coating on the print bed? I know it's temporary at the moment because we're still working on the print bed, but what's that one?
This is literally, Josh, I don't, it's, I ordered it off Amazon. It's like a Creality magnetic bed. I'm partial to the PEI stuff or the spring steel. We've tested all kinds of stuff. Originally we thought, we'll just keep it simple. We'll do PLA. It turns out people want to print other filament, PETG and so on and so forth. So that's why you see the addition of the bed. I'm so old school that in my next room, my little heater closet, I've got a bunch of printers with blue tape. That's old school. The spring steel with PEI is much better. This is like you know, like a magnetic bed here. That's what we're planning on because it's so nice. There's a magnet underneath, a magnet on top. You take it off, you can, you know, it's real pliable. So the coating there is whatever that is, but it's been used in the 3D printing industry for years now.
So next question on stability of the back and arms. It looks like sheet metal. Is there any vibration, any stability problems?
I will say that, you know, if you know my design, I start with minimalistic and then sometimes realize that maybe we need to beef it up a little bit. In carrying this across the room, I don't recommend this, but I'm telling you how I carry it. I will pick it up here because it's kind of like a handle. And I have noticed on this beta, I would like to thicken up that metal. A couple ways to do that. Use thicker metal. It's steel, by the way. All of the construction is steel. Well, the arms, right now, this beta is aluminum. But if we thicken this up, it'll be more rigid and maybe wouldn't, because I can feel just a little bit of give on the top here. But all you do is put a bend in the metal to stiffen that up. So I guarantee that this exact model, which has been done for months and months, so I haven't changed it in months. We've been focusing on the arms and the software and everything else. But, you know, this is, what are we in, Ian? A couple of years?
Yeah, yeah.
Over maybe.
Yeah, 2.5 years working.
Yeah.
Yeah, it's coming on 3 years.
Right? So this isn't, you know, a lot of thought's gone into all areas here, all these guys.
Yeah.
We want it absolutely rigid. In fact, Ian, I'm throwing you under the bus a little bit. He said, can we stand on it? And I was like, we need to make this where we can stand on it. That would be great. I'm not promising that, but we're very interested in rigidity. Even in Thomas, in the Melt Zone or whatever the podcast was, they mentioned, because Thomas, when he came to my shop at Printerbot, we stood on top of an old Printerbot printer together while it was printing. And truth be told, you could tell where in the print we stood on it. It was like, just a little. But I like to make printers that last a long time, so that's what we want this to be.
Excellent. Do you want to talk quickly? I know we spoke about the fan before, but a few people have joined in because obviously the fan is the thing that everyone's been asking. How that fan's working, where the air goes, where the airflow goes, is it enough? All of those different things.
Sure. So this is a Noctua fan. I don't remember the model, but it's a 40mm fan. The reason I have it on this one is honestly to put my best foot forward. We like quiet. We want this to be silent. It does cost, but that beige area there is the side of the fan. One interesting thing about this printer is, you know, originally without the fan for the pictures that we and the you know, the renderings that we did for the Kickstarter, it didn't have this fan shroud. I wanted you to see everything. But when you put this on, it's not too bad. You can see here, there's just a tube, and it's not completely cylinder, but it's a tube. It opens up a little bit, the fan goes on top, and it blows air in past the hot end. And there's a little relief at the top here. There's a little gap to let some pressure off for the hot end fins, the cold area of the hot end. I can grab one real quick. On the hot ends, there's some fins here. You can kind of see. So some of the air blows past that and escapes through the top, and the rest of it goes down to cool. Now, some of you would say, well, it's going past the heater. Is it cold? I can tell you that it's cool air coming out the bottom. So that fan gives enough CFM or cubic, what does that stand for? Cubic feet per minute, I think. Anyway, that fan is not bad. It's not the best I've ever seen. When you go to a more cubic feet per minute, it gets louder. So this is kind of a nice middle ground, but it does force air down. And right now it's just open on the bottom. So on the bottom, you would see like a shape like this, you know, like like that. It's kind of like a dome and then a flat thing. So that is coming in the back, forced down. The weird thing about this printer, the parallel scare arm, is it is rigid. I've got a couple of screws. I don't know if you can see them. And this is just kind of like an add-on, so that'll be incorporated later, but there's a couple of screws here. So when that arm bends, the fan moves. So you end up with, you know, weird angles on the fan. We're used to fans just being stationary and moving in one axis. No, this is moving in a polar axis, so the fan's gonna flip around. But the good, you know, some people were saying, like, why don't you use a different hot end? One advantage of the UBIS hot ends is they are quite long in compared to some of the other shorter ones. A benefit you get is you can fit a fan under there. And even the sensor has room. So it's a challenge design-wise, because when you move that print, when you move that nozzle all the way back, it almost hit these bars. When you move it to the side, it's hitting, like, it's almost like you gotta make room for that hot end everywhere you go. So it's a bit of a challenge, but I'm pretty happy with how it came out. There's all sorts of modifications people could do to improve the cooling if they want more cooling on the print. One really nice thing is this is a stationary bed, which you don't see. I don't even know if there's another printer. Can you think of another printer that does a stationary bed? But that's unique. So whether it's a webcam to do like, you know, what's it called? Time-lapse video or whatever, or it's a fan to cool it. You don't have a moving target here, so there's a lot of options. But it does have a cooling fan. It's one fan that cools the hot end and the print, and that's what you're getting right here.
Okay. Brooke, another question for you. How are we doing homing on the arms?
Pontus should probably answer that.
At the moment, we use this sensorless homing feature of those drivers. So we just move the arm to the extreme position until it bumps into.
So it goes out.
Yeah, into a
Goes
physical.
thick.
The resolution seems to be good enough, I would say, at least for this small arm.
Now, Pontus, tell us, you've used what other methods to home the arms in your earlier printers? You've used end stops, right?
I've been using end stops, yes.
Do you see a big difference between the central homing? These trinamic drivers, they sense, what is it, back EMF or current, something, some magical unicorn tears. They know when they reach the extreme position. So when I hit G28, it goes donk, donk, and it's out here, and then it can do, so X and Y homing is like he said. It's
a physical end stop will have a better resolution, but it's also a whole lot more complicated with wires and things. So if we can get away with the sensorless, which seems to be working fine, it's a better solution.
Let me ask you, Pontus, like what would happen if the X and Y weren't exactly in the right position?
Well, if the software thinks the arms are in a different position than where they actually are, your model is going to get strangely warped and twisted.
Well, but isn't it true though? It might just end up on a different place on the bed, but perfectly fine.
No, it will not. It will get twisted. And...
I love it. It's like, no.
Okay, so we've got a question from Dan, and there's some debate on this one. Could you increase the Z height by moving the hot end closer to the arms instead of having it hanging down below? And obviously there's some questions here about, well, you know, will the joints work that way? Would the fan get in the way? All of these different things.
Right.
What?
Yeah. So every, you know, in a perfect world, you would have well, let me just answer it this way. The motors and the shaft, do I have one here? I don't, but I need a visual. Anyway, the motors and the shaft, the bottom of the motors is here, and I go down extremely close to the top of this bed, with the bottom of the motor, right? So you go all the way down to the motor until you don't want to hit it. And then the top of the shaft is right on the top. So I'm working within a, an area that is the length of the motors that we chose. And I don't know if a lot of people know this, but these are the ones we're using right here. I woke up this morning wondering if we can use a cheaper motor, but I don't know if we can. This is a 0.9 degree motor. Is that right, Pontus?
Yeah.
0.9 degree is it double the resolution?
It's double
Yeah.
from the normal 1.8.
1.8, yeah, right. Math is hard for me, not Pontus. Anyway, so that's the volume that we're working in. So when you kind of just pull this volume forward, so you got the top of these arms, and then you've got the bottom of the hot end. So I am probably giving up, maybe 10 millimeters or something. So I may be able to optimize that further. But beyond that, I mean, you always give up a little bit on the height of your motor on the bottom for the Z, the height of the motor on the X that's moving up and down. I mean, you're never going to get shorter than that in your workable area. So I assure you that we've tried to optimize it. There's probably some more optimization that we can do. It's going to gain millimeters, not inches. I mean, it'll get you like that much more in the Z, but not that much more.
Okay. Next question from Chuck, who's wanting to pimp up his Plybot, is talking about retrofitting an E3D hot end to the machine. Is the UBIS hot end using the same mount style?
Yeah, so the thing that I've always, and by the way, I know the guys at E3D, I speak highly of them. I would think, well, I know for a fact, Sanjay speaks very highly of Carl's engineering and his work. Carl has decades more experience than Sanjay or anybody over at E3D. So he's more seasoned than those guys. But they do good work, and I like that they have produced a pretty much standardized. It was copied by a lot of people, China and a lot of manufacturers, and it's cheap. Here's the reason that I've stuck with. I'm grabbing another visual aid. You'll never get that profile on an E3D. You're going to have a block that's not round, it's a block. And then they're going to shove a cartridge heater, which I forced Carl back in 2012, 13 to do a version of his hot end. This doesn't have a tip on it, but you can see that his hot ends are perfectly cylindrical. You can't get more elegant than a circle. And his the heater is inside a ceramic insulator, and it's actually a very small piece of aluminum. I might be able to show you here. I can take this apart. This is the heater core. So around that anodized aluminum there it's hand wrapped nichrome wire. So the heat is going to get the actual heat from the electricity going through the nichrome wire. That beats the pants off of E3D's heat because theirs is going to go, first of all, they're going to like shove all this nichrome wire in a cylinder, and the failure rate on that is pretty substantial. I'd love to hear them, but we bought a bunch of high-end heater cartridges, just like E3D uses and everybody else. We bought I think Carl told me last week, out of 100, like 6 were bad. They didn't work, period. 100% of these heater cores work because they're hand wrapped and then they're potted inside of a ceramic insulator. So these, and I asked him, I said, how many have you shipped, Carl? He goes, probably 70,000. And I said, how many do you know? How many heater cores do you know have failed? And he said, burned out like the cartridges do? And yeah. He says, I don't know of one. I've never had one burn out. So it's going to be hard to beat the distance from the filament. You can't beat it. It's right next to it. The failure rate, you're not going to beat this. All of these, these connectors, they're properly rated. Carl was a failure analysis. He ran the failure analysis lab at HP, Hewlett Packard, for 30 years. He knows why things break, how they break, how to fix them.
Okay, next question for you, Brook. Otherwise, we'll never get through them all. Okay.
I'm sorry.
It's okay.
These audience are awesome. That's what
this is a good question that's come through by a few people, and it references Thomas and Stefan's podcast as well on Melt Zone, which was, is there fewer parts with this or more parts than a normal, typical looking 3D printer? People can't work out whether this is more complicated or less complicated.
You answer that, Pontus.
Well, mechanically, it's much less parts actually. I mean, there are fewer bearings, and it's mechanically quite simple. It's fairly tricky to get it to work right, but we have managed to do it.
Josh, do you think? Could you add anything to that?
Yeah, I'd say it's a lot simpler. It's hard to define parts because there might be one design that has like 10 screws in an arm that suddenly has more parts than a regular Cartesian, but it's definitely a lot simpler. Like I built ones that just have like 2 bits of plywood at the top, and then the next one has 1 bit of plywood, and then there's a bolt going through and 2 bearings, and that's an arm, and that's one axis. So you double that up, and it's like under 20 parts or so for 2 arms or something. Obviously for this, because it's a bit more complicated, it looks nicer, it'll be a bit more complicated, it'll be a higher part count, but it's definitely a lot simpler than Cartesian designs.
And just on that, Josh, quick question, is there just one motor driving both joints in an arm?
Yeah, so the motor drives the elbow joint, so it's helpful if you imagine it like
there's 2 motors right here and here.
Yeah, so for each arm there's 1 motor, so they drive that elbow joint. So it's helpful to imagine this is like a straight line. So then you have kind of 2 straight lines. This is hard to demonstrate. 2 straight lines enlarging and shrinking to kind of move it around the bed. Maybe you got that, maybe you didn't. But that's how I think about it.
I when designing with Josh here, the shoulder, the motor's at the shoulder, and there's an elbow, and there's a wrist. So that's the way I'm thinking of it, but there's a motor at each shoulder. And there's a belt that goes beyond the elbow, think of it like a tendon, and it hooks to the forearm. So if I want to pull this forearm, straight, I have the motor pull it back. And if I want to pull it I have a belt coming around this side too. So if I want to pull this back, I pull it here. So it's one motor controlling each arm, but they work together. If I were to decouple it here, the thing would just flop around. I mean, you wouldn't be able to control anything. It wouldn't be positioned. You couldn't do the positioning. You need 2. As far as parts too, I do want to say, I've built a lot of printers. There are less parts in this printer, period. There are. And I'll tell you the thing that excites me is it's easier to build. It's easier to build. It's not easier to design. It's not. And it's not, this design is not the design with the least amount of parts. It's not. I don't do that. What I did was I took Josh's design and tried to make it a beautiful intersection between form and function. It's not the least amount of parts you can make in a printer like this, but I think it's the most beautiful with the least amount of parts. It's less than like a printer bot for sure.
Yeah, I think I've covered off the questions in the chat, or other people that are in the chat have been answering the questions for me, which is great. So if there's other questions, please shout them out. So I just make sure we don't miss anything. I just wanted to highlight as well, Plybot has been printing throughout this set. Well, it's been printing for the last few hours before this meeting. And
Yeah.
You know, it's not stopping. It seems to be doing well.
Oh, by the way, just so people, if they haven't asked this, I slice this in Cura. There's no special magic. It is literally just a profile in Cura right now. 0.2 millimeter layer height, PLA. And it's, you know, so it's like your printers. I think it's 60 or 8. I forget if I think it's 60 millimeters a second. Does it go faster? Yes, it can go faster. You know, there's always a payoff. Or, you know, can we go faster? Yes. Do we want to? I don't know, maybe. But I just wanted to let you know it's a 0.2.
Okay, another question just came through, which I think is an important one for a lot of people. Can the belts be tensioned to minimize backlash as part of wear? And can things easily be replaced if things break?
Right now, the tension for the belts are here and here. It's an Allen wrench. You tighten it. The end.
Yeah. So, oh, this is a terrible. But there's a bolt. There's a bolt that goes through there, and you just turn that, and that tensions the belt. So there's a tensioner inside the forearms that just pulls on it.
Just so you know, there's one side that's tied off. It goes around the motor, comes back, and then that's a captured belt, and the screw tightens it. So when you tighten it, the whole half loop is tightened. So yeah, and can you? Yeah, you know, it's funny. I told the people earlier, this design is a few months old because once you get the mechanical design, you got to get all the software working and stuff. So I haven't really done anything significant except for the fan shroud and the sensor since, you know, I don't know, November. But in that time, you come up with better ideas. So there will be changes. These arms, and Josh, he had to build one recently. And while I gave him a kit and like tried to make it easy, it's not where we need it to be for shipping yet because there's a lot of improvements we can make for manufacturability. When we make it more manufacturable, it will simultaneously make it more serviceable. And that is our intent.
Yeah. A couple of questions again. Does it come assembled? Yes, it does. It comes out of the box, plug it in, load the filament, and you can print using it. Talk about the extruder.
It's really a kind of a follow-on to the gearhead. When I won't go long on this, Ian, but I was the first one to come out with the dual gear extruder. The very next day, Bondtech came out and he wrote me and he says, "Dang it, I thought I was going to be the first, but you beat me." Well, I was the first, but he actually had a better design. I was using a cheap pinion gear that didn't have the resolution. It's just more gears in his pinion. And he used a more precise way. So anyway, these are Bondtech. I say Bondtech-like, because I don't know if I bought them from Bondtech or somebody that did the Bondtech. I don't know. If Bondtech is out there and wants to sell it to us really cheap, we would love that because we love the Bondtech dual gears. They were better than what I did originally. But it is a cheaper extruder than his. This one on here happens to be 3D printed on an HP Jet Fusion or Fusion Jet or whatever it's called. So we're hoping to do some really clever things with our manufacturing to get the cost down as far as possible. But I got to tell you, this one, and I have another one in another printer that uses like a geared, like a geared stepper. Those Bondtech gears are awesome. It's a dual gear. It's not just like the old gear head. It's even better. So it's the best one I've ever made. That's what we're using.
Okay, great. Have we got any plans to do a kit that people can build themselves?
No. Okay. I don't know. Ian, you answer that.
I would say no. Our target for this is simplicity, out the box, it works, no messing around. The reason for that as well is
it's always a trade-off.
When we ship these, we want it working perfectly.
Yeah.
So if people are putting it together, I'm not saying it won't work perfectly, but the QA,
I mean, hey, Ian, close your ears. If you guys want a kit, just instant message me later and don't tell Ian you're going to buy it from me on the black market, and I'll send it to you so you can put it together yourself. But it's just, yeah, the makers, I get it, why you want to build this thing. And it's not that hard to build, but what happens is you open yourself up to a whole bunch of issues because people, trust me, people will order a kit when they should have ordered the assembled thing. So you say goodbye to a lot of headaches if you just build the thing. If you want to take it apart, once it gets to you into all separate pieces and then put it together yourself as a kit, then maybe that's the kit will.
And I think I'll just reference into that, Brooke, because I can see some of the other comments coming about it. So yeah, once these Plybots are out there in the open, and people will obviously take them apart and do things with them, obviously, and customize them and all of these different things. And you know, if they can be self-supported by the people that own them, it's better for us. So we will make that simple, easy. We'll set up some nice communities that's run by the people that own them that can actually share some of the ways in which they are enhancing them, customizing them, and fixing them. So that, you know, in turn, us focusing on making that as good as possible is good for us as well. So yeah, you know, we want you to be able to repair them, and we don't want them to break in the first hand. You know, in the first instance, these things shouldn't break; they should last. But if anything does happen, then if you can fix them, great. And if not, it's going to be one of those you send them back, we send you something new.
Yeah. I you know me, if you've followed me for years, you know I love, it's what I would do. I ordered so many printers on Kickstarter. I did one print and then tore them apart. Some of them went in the trash. I think everybody's going to be surprised at how simple this thing is. There's no secrets, but what you do is you take careful planning, and it's kind of like the sum of the parts are greater. You know what I mean? It's like, for some reason, when you take really careful time and energy to make sure that you're making all the right choices, it ends up being a great printer. But there's no secrets. I think a lot of people will be like, wow, this is cool because it's simple. Well, simple is hard. Trust me. But we're proud to put it out there, and we welcome people taking it apart, but you know, void your warranty. Yeah, we haven't got into customer service yet, but it's tough.
Yeah.
I'm pulled between those two worlds, you know. I want it to work. I want makers to have fun.
Does the assembly or disassembly require any specialized tools?
No, I think there's a Phillips screwdriver and a couple Allen wrenches.
Okay, that's good. What are the arms made of? Are they metal or injection molded?
These, and I've been saying this to Ian for a long time. This looks almost as good as I wanted it to, but I think we can do a little better. Right now, this is actually, I bought these aluminum extruded square tube. It's like 1-inch tube in America. It's just extruded aluminum tube. I bought it at Lowe's in Wichita. I cut them with the chop saw. And then I did these 3D printed hinges. Very tough to get those exactly where you need them to be. So those will probably, the whole top surface on one joint will be a piece of metal that's all joined. No like fitting into extruded holes. We can do better on this design, but it looks pretty good. It looks good. And to be fair, there's a couple of places where I didn't want to reprint stuff at the perfect whatever. I epoxied them in there. So just know this is a beta. We're going to make a manufacturable one that's easy to take apart. So what I'm thinking is either a sandwich of like Delrin or HDP. I always get this wrong. The plastic. We'll either mill some plastic in between a sandwich, or we'll figure out a cap for like a couple of folds of steel or aluminum. But we're going to try to minimize the parts and give them the most rigidity. You know, Pontus, to his credit, he's the one that he's been fooling around with Scara stuff for a long time too. And he kept saying rigid, rigid, rigid. It has to be rigid. You need it super rigid, 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 rigid. Get good bearings, get good bars, get good bearings. So we have a lot of people reminding me that if we're gonna have to build thousands of these, we need it rigid. It affects the math. It affects the printing, right, Pontus?
Yeah. I'm conscious we've got 4 minutes left. Another question. Any chance moving to a mechanical probe to use glass?
They're probably talking about what is the probe? The like beep, beep, the what's it called?
BL Touch.
BL Touch. Pontus, is there a difference in the software between a BL Touch or a?
No, not really. No.
Yeah, you can use whatever you want. You know, you'll have to know how to set up. Clipper is interesting because I'm editing a text file to change. Like I added the heat bed yesterday. It was I copied and pasted some text.
Yeah. Just a question on here, which is again an important one. I don't want to sort of sidestep. Someone said, "Is there a warranty on the Plybot machine?" This is something we're working through at the moment because we have a few schools that are going to be taking these, and we're looking at any problems with them. They send them back, and we just send them a new one straight away. So we're looking at ultimately providing sort of a 12-month warranty on these things. Don't hold me to that. It might be better than that, but we just want to confirm everything. The key thing for us is build quality so that this thing doesn't come back. It keeps working, and it's difficult to break. I think one of the other things, one of the questions as well, now we've added the fan on here, which wasn't on some of the renders on the Kickstarter campaign. A key part of why we didn't put it on there as well as it makes it a bit more bulky at the hot end, but also we wanted to see how we could use that to protect the hot parts of the hot end from children's kids' fingers. So that covering that we got on there helps to do that. But the only way now they can actually burn is putting their finger actually up the hole as opposed to just touching something. So that was a key consideration for us as well on that part.
By the way, this the design of this is kind of fascinating. This will be able to be made in metal. It's printed right now. It's actually PLA right now, but that is such a simple design. We'll be able to do it in metal, protect, direct the air and protect little fingers.
Have you tried printing with Windows 10's built-in tools? Just curious if it's plug and play with that.
Yeah, the Windows, I knew the guys that were on that 3D printing team from way back when they first started, and they do a good job. This is right now, again, full disclosure, I hope I don't break anything, but it's at the end, so it's okay if I do. Right now, this is a Raspberry Pi running Octoprint. It's connected through USB at this moment. There's a SD card slot right here. I mean, it's an off-the-shelf SKR board. We'll use whatever the best choice is when the time comes. But right now, this is, it's running Octoprint and it's wireless. I can use it on my phone. So you can use it on with anything. Clipper it works with all operating systems, right? Windows, Mac, Linux. It depends on the software you want to use. But the ideal situation for me, and this is just me sharing my interest and heart for education of kids, is this is the computer that kids are using, honestly. My son doesn't own a computer. I offered him one because I have like 6 left over from Printerbuy. He's like, I use a phone. So there will be an app on the phone that operates this printer via Wi-Fi, and we don't lock you into it. So you can use it on Windows, Linux, or Mac. Yep. Choose your own software. Pontus, you have anything to add?
No, not really. No.
Yeah. Some of the other things on here, I think, which will be built, we've got on our list, auto resume if there's a power outage, those sorts of considerations. I
don't have that set up right now. I don't have it. If the power went out, this would stop. Just full disclosure. But I know that Prusa, there's some clever firmware stuff that you can do to give yourself time to save the file and then restart. Haven't done it. Haven't ever needed it.
Okay. So I know we've hit 11 o'clock now, so a number of people are dropping off. I've got to go back to work. Hopefully you found it valuable and useful to see Plybot working. In that you say it's working in the background. It hasn't disrupted us from a noise perspective. And Brook, Pontus, Josh have been giving some honest answers to all of your questions. If there are further questions, I would say pop them on the comments section of the campaign. You know, put them open so everyone can see them, and then we'll respond to them openly and honestly. What we're hoping to do is do another demo probably in the next 2-3 weeks as the campaign progresses, where we can hopefully share with you the software as well, running on a mobile device, so we can show you the test software and how it potentially works, and we can, you know, share with you some of the further enhancements on the printer itself.
Yeah, I really appreciate everybody's time just to pop in. I see some familiar names. It's just fun to be back in community with people, so we'll do a good job for you.